Okay, so this is Edexcel June 24, further maths. It's Core Pure 1, and it's the last question on the page, and it's coupled differential equations. These can be a bit interesting, so let's have a look at this one. So you get your two differential equations. Part A is you need to show that this results in this second order differential equation here. And just a little point, I know they copy these afterwards when they someone takes them away and copies out the questions, so they then put them onto various websites and stuff like this, like their own Edexcels, and someone's miscopied it, and that was as a Y. So if you have a copy or you're looking at a question that says Y there, it isn't, it's meant to be an X there. So anyway, this is the original question. So what we've got to do basically is we see our second order differential equation is in terms of x and t. So we need to eliminate the y's simply. So we're going to start off, because we've got a second order differential, is taking our differential equation with the dx by dt and just differentiating it. So as we differentiate this with respect to t, dx by dt becomes the second differential. X, when you differentiate it, becomes dx by dt. And y, when you differentiate it, becomes dy by dt. Now that's all nice because we've got a dy by dt here, so we can basically sub in dy by dt as 3y minus 2x in for this dy by dt. So we're then going to get second differential equals dx by dt plus dy by dt, which is 3y minus 2x. However, we don't want a y in there, we just want this in terms of x's and t's, so we go back up to our first one, rearrange that by taking the x over, so our y would equal dx by dt minus x. And so we're going to replace the y in there with dx by dt minus x. And that should now fall all into place, he says. Let's have a look. Plus 3y, so 3 lots of that. And that should now work. So we've got dx by dt, 3dx, so we've got 4 dx by dt's. Well, let's not be lazy, let's actually write it out. Equals that, 4 dx by dt's. Minus 3x, minus 2x, minus 5x, and so when it all goes over the other side, don't forget, don't lose that final mark by not actually writing out, exactly what they want us to prove. Plus 5x over the other side, boom. Okay, so we've done part A. We proved that this comes from these coupled differential equations together. Then part B, we got to determine a general solution for the number type of A bacteria at time t days. And the A bacteria is the population of the A bacteria. Yeah. So I'm going to solve this differential equation. So it's a nice straightforward one in that we just literally, so we're going to do particular a complementary function is m squared minus 4m plus 5 equals 0. So you turn this into a quadratic and usually use m as our variable there. And we just solve that. And that doesn't factorize. So, don't make any sloppy mistakes. Reach for your calculator if you so desire, but I'll just stick this in. It's a quadratic formula. So b squared minus b minus b plus or minus b squared, so that's going to be 16 minus 4ac, so that's going to be 20 all over 2. Yes, we're going to get ourselves a little bit of a complex solution here. So that's going to be 4i root 4, which when you square root becomes 2i, so it's 4 plus or minus 2i over 2, so therefore m is, divide the 2 in, 2 plus I or 2 minus I. Okay, so if you remember, that leads to a solution that is x equals e to the real part, so 2t, and then the complex part turns into the trig formula, so it's going to be a cos, and we've got just one t there, because it's one I, plus b sine t. Lovely. All done. Okay, so that's part B done. So determine general solution for the number type of A bacteria at time t days. And then we've got to determine a general solution for the number of B bacteria. Now B bacteria is your Y's. So we can now basically say, right, we've got dy by dt equals 3y minus 2x. So I'm just gonna, oh no, oh, silly me. I'm gonna go for the first bit. So our first differential equation, I've been daft there for a second. What is it, x plus y by x plus y. Okay, so we know dx by dt equals x plus y. We basically want a formula for y. We've got a nice formula here for x. So we're going to find out what dx by dt is by taking this and differentiating it. Whew. So we've got a bit of a product rule going on here. I'm going to call that my u and that my v. And so when I differentiate this, I get 2e to the 2t. So dx by dt is going to be 2e to the 2t times that. Plus u times the differential of v. So that's e to the t times the differential of v. So a cos t differentiated is minus a sine t. And b sine t differentiated is b cos t. Right, let's group these together. So we've got e to the 2t there that we're going to take out as a common factor. And we're going to have 2a cos t's and a b cos t. So altogether 2a plus b cos t's. Yeah, 2 times a there for number of cos t's, and then a b cos t there. And then for sine t's, we're going to have 2 times b and then minus a. So plus 2b minus a sine t's. Right, that's our dx by dt. So we've taken our general solution for x. We've differentiated to get x by dt so that we can then come to this. And obviously this is y equals dx by dt minus x. Just take the x over the other side. So we get a nice little thing in x. We've got y, sorry, making the subject. So we can now write out that y equals this horrible thing minus x, which we know is this thing. So it's going to be pretty lengthy this, but here we go. So y equals this. I'll write it all out. So we've got 2a plus b cos t plus 2b minus a sine t's. So that's our dx by dt done. Minus x, we got a minus this. Oh dear. I'm going to run out of room, but I'll try and squeeze it in. E to the t, a cos t plus b sine t. And again, let's group them together. So e to the t, so we have y equals e to the 2t, sorry. There now, cos t's. Here we've got 2a plus b. Here we are subtracting a b. So we're just going to have 2a cos t's. Is that right? No. It's a cos t there, sorry. There we go. So 2a plus b cos t's and a minus a cos t, so that's just a plus b cos t. Oh, almost went wrong there for a minute. And then sine t's, I've got 2b minus a, take away b, so that's b minus a. Whew. And there's my equation for the general solution for y, which is the number B bacteria. Right, what's the next thing? The model predicts that at time t hours, and I'll flag it up now because we're going to come to it later. This is in days, t is in days, and they want t hours. So we're going to have to remember that at the end, that we're going to have to do a little time conversion. The number of bacteria in the two populations will be equal. So how many we've got in X will be how many we've got in Y. Okay? Given that X equals 100 and Y equals 275, when T equals 0, determine that value of T. Okay, so as soon as you see some initial conditions, you know you're going to have to find out what the constants are. So we're going to be putting in T equals 0 and our X and Y values into these two equations. So let's see, I'm going to rub this top bit out now, give myself some space. Shall I very quickly just write these down again? So e to the 2t and a cos t plus b sine t. And the y1 is e to the 2t, a plus b cos t, and b minus a sine t. Right, so we know when t equals 0, x equals, what's it equal, 100, and y equals 275. I can rub all this off now. Lovely. Okay, so let's bung these in. So x is 100, t is 0, so you've got e to the 0 there. Obviously that's going to be 1, that's going to be nice. We're going to have a cos 0 plus b sine 0. And we obviously know when sine of 0 is 0, cos of 0 is 1, that's e to the 0 is 1, so we're just going to end up with 100 equals 1, a, nothing, so 1a, so a is what, 100. Put the 275 in for y, so we're going to get 275 equals, again, e to the 0. Now, should we use the a straight away? We know it's 100 up in there, so we're going to have 100 plus b cos 0 and plus b minus 100 sine 0, which is pointless me writing out because we know sine 0 is 0, so that's 0, that's 1, so it's just 100 plus b equals 275, so b is 175. Whew. Okay, now the whole question is about when the value of t when the two populations are the same. So we're going to equate this, that equals that. We're putting in, I'm just going to leave it as t at the moment, leave it in terms of hours, we'll worry about the conversion later, and we're putting in a is 100 and b is 175. So on the x side, we got e to the 2t, which I'll write down even though I can see it's going to cancel. A cos t, so that's 100 cos t, plus 175 sine t, because b is 175, equals the y formula, e to the 2t. Yeah, you can see these are going to cancel. Right. A plus b, so 100 plus 100, so 275, oops, 275 cos t, and then b minus a, 75, oops, yep, 75 sine t, lots of oops in here. Okay, so, lovely, cancel. Let's group all the coses together and all the sines together, so that over there gives me 175 cos t. And that over there gives me 100 sine t, and then cos over there, 100 over there, that's obviously tan t, 100 175 over 100, too lazy to cancel down. And then you inverse tan. An inverse tan of that, oh, I better do that on the calculator quickly. Oh, sorry, excuse me. Whew, what are we doing? Shift tan to the -1 of 1.75. So it gives me 1.0516, and then don't forget that is days, and it wants T, big T, capital T, in hours. So T is 24 lots of that, because obviously 24 hours in a day. And that equals what they want to do, 2 decimal places, 25.24. Boom, done. Excellent. Wonderful, wonderful, wonderful. Right, that's 15 marks this question, and we still got a mark to do. We've got the limitation of the model, who would have thought? Right, and usually, like I've said before, with limitations, you're looking for, are there any values T can't really take? What happens when the T value in this case becomes really, really large? Is that going to be a problem? Are we going to get negatives flying around? And with this one, if you think about it, as T becomes really, really large, well, that's always going to be a nice positive number, e to the 2t. So we're going to get positive numbers here. However, because we've got trig functions here, they're going to become negative at some point. They'll be positive as well, but there will be some values of t that basically, when you've got have I written them out? Yeah, well, it doesn't matter. When you've got your value of t, you might get cos being negative, and the sign might be positive, but the cos might be bigger than the sine and that become negative, or the other way around, the sine becoming negative when the cos is positive, or them both being negative at some particular values of t. So this term here can be a negative. And obviously, positive and a negative, we're going to end up with x being a negative number. And the same for y down here. We're going to get some negative numbers sometimes for values of t. Well, X and Y are the populations of these bacteria, so having a negative number doesn't make sense. So that's your limitation, just that for certain values of t, you are going to end up with negative values for X and Y, which is not possible. Okay, 15 mark question, big one. Hope that all made sense.